If you think large language models are the absolute peak of AI, well, you might want to buckle up. Today, we're diving into what a lot of people are calling the next great leap forward, AI world models. So let's start with a little puzzle, right? We have AIs that can compose beautiful poetry, they can write complex code, but if you ask one what happens when you drop a cup, it kind of short circuits. It knows the words drop and break are often used together, sure, but it has zero real understanding of gravity or fragility. It's missing a huge piece of the puzzle. And today, we're going to figure out exactly what that piece is. Look, we've all played around with LLMs, like GPT. We know how incredibly powerful they are. But you've probably also run into their weird little quirks, right? These fundamental blind spots that show you exactly where their so-called intelligence hits a brick wall. So what are these blind spots? Well, for one, LLMs hallucinate. I mean, they'll make stuff up and state it with absolute, unshakable confidence. They have no common sense grasp of physics. They just don't get that things fall down. And because they can't really simulate what happens next, they can't truly plan ahead. They're all gut reaction, no deep thought. A really great way to think about this is the smart parrot analogy. The AI is a master of matching patterns. It's heard rain and wet in the same sentence millions of times, so it squawks wet when it hears rain. But it has no idea what water is or why rain makes things wet. It's just brilliant mimicry, not real understanding. Okay, so if what we've built is a world-class parrot, what's the next step? How do we give it genuine comprehension? How do we get it to go beyond just shuffling words around and get it to actually understand the world those words are describing? And this, right here, is where the idea of a world model comes in. Now, the key thing to get is that this isn't about text or language anymore. This is about building a simulator, a little virtual copy of reality, right inside the AI's own mind. You know, think of it like a flight simulator. Pilots can practice super risky moves hundreds of times and crash 100 times in a simulator before they ever try it in a real jet. A world model gives an AI that exact same kind of safe space, a playground to learn about the world where mistakes don't have, real-world consequences. So how does this whole simulator thing actually work? Well, it's a constant three-step loop. First, it perceives the world, what's going on right now. Then it predicts what will happen if it takes a certain action. And finally, it simulates all sorts of different possibilities. And this is a huge shift. We're moving from the LLM's question of what word comes next to the world model's much, much more powerful question, what happens next? You can really see the difference right here. On the left, you've got the LLM. It's basically a one-way street. Text goes in, some statistical magic happens, and text comes out. But look at the right. The world model is a dynamic cycle. The AI acts, it sees what happens, it updates its internal model of the world, and then it plans its next move. It's this constant loop of learning and interacting. Let's break this down just a little bit more. Your classic LLMs are generative. They're trained to fill in the blank and just predict the next word. And this gives them a fantastic feel for how words relate to each other. World models, though, are predictive. They're trained to predict the essence, the gist of what happens next. And that gives them a way deeper understanding of cause and effect. And this brings us right back to our analogies. The LLM is the parrot, just memorizing that the words glass and break show up together a lot. The world model is way more like a toddler. A toddler doesn't learn about gravity from a textbook. They learn by pushing their cup off the high chair over and over and over again. They're building this intuitive model of physics through pure chaotic experimentation. Okay, so this isn't just some cool academic theory. This is already having a massive impact on technologies that need to, actually interact with the real physical world. This is where it gets really interesting. Just take a look at this example. An autonomous car isn't just seeing pixels and slapping labels on them like cyclist and pothole. Its world model is running a simulation. It's actually predicting that the cyclist will swerve to avoid that pothole, a future that hasn't even happened yet. And because of that prediction, it plans to brake now. That's the incredible power of having a physics engine inside your head. And this goes so far beyond self-driving cars. This technology is an absolute game changer for robotics, letting a machine imagine the best way to pick up a tricky object. It's the secret sauce behind those mind-blowing video generation models like Sora. They're basically world simulators. It can even be used for scientific discovery, simulating complex molecular stuff that would be totally impossible to test in a real lab. So this leads to the big question on everyone's mind, right? Does this new shiny tech make the LLMs we've all gotten used to totally obsolete? Is it a complete replacement? And the answer from pretty much all the experts is no. It's not a replacement, it's an evolution. The future we're almost certainly heading for is a hybrid system, where these two kinds of AI work together, each one playing to its own strengths. Here's a great way to think about this hybrid future. The LLM. It's like someone who has spent their entire life in a library and has read every single book ever written about hiking. They can tell you anything about it. But the world model? That's the person who has actually gone on the hike. They know what it feels like to have loose gravel slide under their boots. One has knowledge, the other has understanding. And to get to real, robust artificial intelligence, you're going to need both. You need the book-smart librarian to handle all the knowledge and the language, and you need the trail-smart hiker to ground all of that knowledge in the reality of the physical world. So where is all this actually going? Well, this combination, this fusion of language mastery and real-world understanding, it takes us right to the doorstep of the holy grail of AI research, artificial general intelligence, or AGI. I mean, think about it. You can't have a truly general intelligence that doesn't understand the basic rules of the universe it lives in. AGI has to be grounded in our reality. It has to get time and space and cause and effect. And right now, world models are our best shot at giving AI that essential foundation. And that's really the thought I want to leave you with. For years, we've been focused on teaching machines our language. Now, we're on the verge of teaching them our reality. The question is no longer just about what an AI can say, but what it will be able to do. What happens when an AI doesn't just know our words, but truly, deeply understands our world.